This is the third and final step in the Gantenbein winery. What we've done so far is created the surface, divided it up, and then created the every other running bond pattern. And that's what I have here is the merged brick points. You can see those are actually coming from the very last component, the merge from the end. And because those are individual brick points, I used a point parameter like up from up here. Now here's the step-by-step instructions, what we're going to do. In this step, which is the step 02, create and rotate the bricks based on the sphere image that was supplied. To do that, we need to create the bricks at each of the merge intersection points that are showing up in green over here on the left. We need to decompose the points and replace the y, z values. I'll explain that more, but that has to do with the fact that a domain is set up for x and y, and these points are along the x z-axis right now. So we need to keep the x information, but replace the z with a laid out y information. Okay. Sample the image from the grayscale values, set the domain to the overall object dimension, which is 780 by 260, and then remap the grayscale values from 0 to 1 to a 090. This would be like 90 degrees. Possible rotation. And quite frankly, this is going to become variable. We're going to adjust this kind of on the fly. And then last but not least, actually rotate the individual bricks. Okay, so like I mentioned, I have a point component here acting as a container, simply wirelessly bringing down my point information from above. I need to do the same thing with the brick dimensions. So let's go to the very beginning. The 4 panel tools up here have the brick height, width, and depth, as well as the mortar thickness. We don't need the mortar thickness, we just want the brick height, width, and depth. To do that's considered a number, so let's go to primitive and number. I'm going to go ahead and relabel this as brick height, or width, excuse me. And we're going to also copy paste, make 2 more of these, make one for the height and one for the depth. And we're going to go ahead and wire these together, as well as make them wireless receivers. Now, again, it's really important to use the number, not the integer, because if you use the integer, it's going to round all these numbers up to their nearest whole number. We want to make sure we maintain the decimal and use the number component. Okay, I'm going to right-click wire display and set it for hidden on all 3 of these. And I'm going to go ahead and take these down below so we can use them in that next step that we are working on. Again, we don't need the mortar information right now. Whoop, I set that one wrong. Hidden, there we go. So we can go ahead and bring this stuff down below. Now what we're going to use for this, again, we've used it all the time, is the box center information. So let's go underneath our surface, primitive, box center. The box center is asking for a plane. We're going to use these points, and we're going to put them on the XY plane. So we don't really need to put a plane in here, but we will use it here in a moment. So let's go ahead and do it. Go to vector, plane, and make an XY plane. Run these through that XY plane and those planes into the B input, the base plane input of the component. I'm going to turn off the preview for that. I'm also going to turn off the preview for my box center points. Now we're going to use the widths, the heights, and the depths, like so. But again, we need to remember that the box center point doubles everything in the positive and the negative, so we want to divide all these. So we're going to set expressions on all the x, y, and z's as an expression of x divided by 2. Go ahead and do that for all of them. And there we go. If you look closely, you should notice that the bricks do not overlap because they all have that mortar thickness assigned to them. Perfect, and that's how you know you've done it properly. Let's go ahead and just group all that together. Now what we need to do is deal with the actual image mapping, the sphere itself. To do that, we need an image mapper and an image sampler. Go to parameters, input, and image sampler component. And let's go and find the sphere, wherever you save the sphere from. Let's go ahead and save that. Go find that. And be sure to set it to the color brightness as the channel here, because we want to sample the grayness, the grayscale value of their color brightness. Now the domain we're going to set to match the overall width of our entire facade here, not just the width of the panel. If you only set up the domain to match the width and the height of the panel, this sphere is only going to get mapped to this panel. We want this panel to only sample the lower corner of the sphere. So to do that, you have to tell it that the entire facade is the domain. Now I've already measured this ahead of time. The X domain should be something between 0 and 780. And the Y domain 0 and 260. Hit OK. And you'll notice that that's where these values up here set the overall domain in the image sampler to match the overall dimension. That is from this point in the lower left to this point in the lower right, 780, and 260 is roughly the distance from that point in the lower right to this whole point in the upper right. That way the image gets mapped on this entire facade. Yes, it will be stretched, but that's okay for right now. Now we have to go ahead, and the domain is X and Y's, but right now all of our data has unique X and Z values. That's just showing boxes for right now. So we need to break down the values, the point location values here, and swap out the X and Z values. We want the actual point location information coming from our merge points. And you'll see they have all the same Y value in here. The uniqueness is the X and Z. So we need to swap the Y and the Z values. To do that, we're going to go underneath our vector, point, and deconstruct your point. And the points you want to deconstruct are the merged brick points right here. Let's bring that in there. And now that'll extract the X, Y, and Z values for every single point. Then we're going to go to vector, point, and reconstruct a point. We want to maintain the X values. We're okay with that. But what we want to do is swap the Y and Z values like so. Now we're going to use those points, and you'll see when I do that, and in fact you don't even have to run the Y into the Z if you don't want. You can just run the Z into the Y in the first one and leave the other one blank. You'll see what we get now are values in the X and Y location. Remember, our domain is an XY domain. If that domain was X and Z, we would have been fine because we previously had values in X and Z. But now we have them in X and Y because our domain requires X and Y values. Okay, so hopefully that makes sense. Again, I always like to put a little panel tool in here to remind myself what I set the image sampler to. So what I do is I'll say my X domain should be 0 to 780, and my Y domain should be 0 to 260. And then I'm going to also set it to grayscale, just so I remind myself what this is all set up for later on. Like so. Okay, now I can group all that together. Alright, so these values right now are between 0 and 1 because grayscale value is always measured between 0 and 1. It's giving me the brightness, 0 being light and 1 being dark within there. Okay, what we need to do is reassign these values from 0 to 1 to some sort of idea of a rotation angle, where 0 might become a 0 rotation, where a value of 1 might become a 90-degree rotation. To do that, we want to use the remap. So go to Math, Domain, and Remap Numbers. The values that we want to remap are easy. They're coming straight from my image sampler. The source is what the image sampler is currently giving us right now, and that domain is 0 to 1. If I hover over that source by default, you'll notice that it's actually set to 0 to 1. But just to make our life a little bit easier, let's go underneath Domain, Construct a Domain. Let's put a value of 0 in the A input. So we're just going to do that with the panel tool. And we'll put a value of 1 into the B input. And that'll make a domain of 0 to 1. Remember, the source domain should match the output of the image sampler. So what I'm getting from there should match my source domain. Now my target domain is what I want them to be. So I want a 0 value to be essentially a 0 rotation, but I want a 1 value to be a rotation maybe all the way up to 90 degrees. There we go. So now you'll see what I get is no longer values between 0 and 1 like they were here. See all those between 0 and 1? A lot of them are very similar values, but 0 to 1. Now the results are values between 0 and 90, which can become rotation angles. Great. Go ahead and group all that together. And the last step is to actually rotate. So we go to Transform, Euclidean, and we're going to go to Rotate. And there's several ways to rotate. The first one's the best option because we're going to rotate them about a plane. And don't forget to turn off some of your old stuff. There we go. And now, the geometry I want to rotate is easy. Those are the original boxes here. Once I wire these together, I'm going to turn off the original boxes. So wire that in there. Right-click, Preview Off. And you'll see it's actually rotated over there because right now it's using this fictitious plane at the origin and essentially just swinging that whole facade along a positive 90-degree rotation to now along the y-axis. But we don't want to do that. We want to rotate them all about their own center point or their center axis. So the thing we want to do now is let's skip the A for a moment. The plane I want to rotate about is their own center planes. That's why we use this XY plane, because these represents planes for each center of every box. So let's go ahead and wire that into the P input like so. All right. And now you'll see what happened is it rotated every brick. It rotated every brick 90 degrees about its own center point. Not quite what we want to do. Let's go ahead and we want to use these angles. Now, A input is asking for radians. We need to convert that to degrees. So right-click, set to degrees, and now rotate these angles into there. And now what you should start to see, and I'm going to turn off some previous stuff. There we go. So you should start to see from the right angle, the proper angle, there you go. You can see this arc happening, right? This is the lower arc of the sphere, the lower left portion of the sphere. Okay, so we've successfully mapped and generated this on the lower left. Now what you need to do is mimic this for the other 5 panels, and it's actually quite simple. There's an easier way to do it, but for right now I'm going to do it the kind of sloppy but quickest way, which is to Control-C, Control-V, copy-paste everything, bring it over. Now what I want to do here is go ahead and reassign different points. So I'm going to use the points in the upper left. So I'm going to right-click, set one point, assign this point up here. And this might be a little slow, so you may want to go ahead, mine's being really slow, you may want to go ahead and disable everything after this for right now. And disabling essentially stops the flow of data. So you're going to set one point lower left, set one point lower right, set one point upper right. And now assign a new surface up there. I'm going to right click. Now you'll notice we're getting a lot of duplicated information. We may want to not copy paste these, but wire them from the original. So that way if you ever change the brick information here, you don't have to remember to change it everywhere else. Okay? So these may want to be copy pasted from over here. So let's do the same idea where we go to parameters, primitive, and number. Let's relabel this as brick width. Make it a wireless receiver and wire this in here. Remember that's a number component, not an integer component. I'm going to copy and paste it and wire it for the height as well as the depth. There we go. Make sure they're all wired properly. And this time I am going to do one for the mortar thickness. Like so. And let's bring these all over here. And all we're going to do is replace these wires here. So what I'm going to do is replace the brick width, replace the brick height, and then run the mortar thickness into the same 2 locations. So that way I no longer need these items, and these have all kind of taken their place. Now they're wireless receivers, and they're linked into the original ones here, so when I change these, they'll automatically update over here. Go ahead and group this. Go ahead and re-enable this panel, and let's see what we get. It's going to take a second to generate. And here we go. So these guys, they previously were wired to the panels I deleted, so I'm going to have to rewire these. So again, brick width is coming from here, like so. Brick height is coming from here, and brick depth is coming from up here. There we go. Okay, so now you'll see I get the other portion of the sphere, the upper left portion, and that little kind of that little hot spot in it is starting to show up right there. So what you're going to want to do is continue doing this 4 more times. This one now, we've already rewired everything, so quite frankly all you should have to do is reassign the points for each one, and you should be good to go. You're going to want to go ahead and save that. In terms of what you need to give me for the actual file, we'll talk about that a little bit more in the assignment portion here in a second. But basically, because you are not doing anything to the original Rhino file, I don't need the Rhino file. I really just need your Grasshopper file. I have the image, so you don't even have to send me back your image sampler. If you decide to use a different image to apply here, which you're more than welcome to do, if you use a different image, I will need a copy of that image. And you can zip all those items together. Again, I'll talk about that further here in a moment, but that'll walk you through how to create the Gatenbein Winery example on a facade. All right, see you soon.